Hi, welcome to SS 8.1 Pythagorean Theorem. Now this is a really cool unit in math and it's very useful in your life. You're going to use it again and again and again throughout your life. And it's a very simple little theory. This section right here, a squared plus b squared equals c squared. That's one of the key things you need to know. And the other is this word right here, hypotenuse. If you understand those two things, you will have no problem with this outcome. So let's talk a little bit about this guy down here in the bottom. Pythagoras, he was a Greek philosopher and mathematician, one of the very first, because he was born in something like 569 BC, a long time ago. So although his theory about Pythagorean theorem, which was all to do with right triangles, 90-degree triangles, that one was pretty good. We'll give him a check mark for that one. But he also had some very other crazy ideas, such as there was no such thing as irrational numbers. So, for example, if you try to do 22 over 7, that will be a decimal that just goes on and on forever. So he didn't think that those existed. He also felt that you should put your right shoe on first. Not sure why, but it was like a rule. You had to. And he also thought that the Earth was the center of the universe. And so there's Earth. Maybe he even thought the Earth was flat, I don't know. And that the sun rotated around the Earth, which we know now is totally false. But good work on the triangle, buddy. You got part of it right. Okay, so on with Pythagorean theorem. Here's the formula. Memorize that. You're going to need that for the rest of math and your life. Always know that it has to be done on a right triangle. You cannot do Pythagorean theorem on any other kind of triangle. It has to have that 90-degree mark. And we need to figure out what this crazy word hypotenuse means. So hypotenuse is the longest side in a right triangle. No other kind of triangle can have a hypotenuse. It has to be a right. So with the kitty here, this corner is 90 degrees. And the longest side is always directly across from your 90-degree angle. So look at the side that's directly across. It is the longest side. Nice straight line. Ooh, look at me go. Yeah. And so therefore it is called the hypotenuse. Okay, so we know what a hypotenuse is? Yes. And we've got the formula memorized? Yes. So how did the two go together? Well, if this is side A and this is side B, the hypotenuse is going to be side C. So in your formula, if I square this number and add it to the square of this number, it is going to add up to the square of this number. So what Pythagoras figured out is that he actually probably made squares and laid them out like this, and he realized that if this was 3 and then I took that side and drew a full square for a total of 9, and this was 4 and I took that side and squared it, drew a full square, for a total of 16, that those two always added up to this third square. So 9 plus 16 is 25, and that we know is 5 squared. So a squared plus b squared equals c squared. Remember that c is always our longest side, that's always the hypotenuse. And we said a was 9, or sorry, A was, the side was 3, and B was 4, and our hypotenuse ended up being 5. So the common misconceptions on Pythagorean theorem are that we forget the squared. A squared plus B squared equals C squared. So one of the common misconceptions is that people will go, well, if this is 3 and this is 4, 3 squared plus 4 squared equals, we don't know yet, C squared. 3 squared is 9, 4 squared is 16, and then maybe they'll just do this and say, oh, 25 equals C. But you see, I had a squared going, and then all of a sudden it's gone. So remember to keep your squared all the way through. And if you know anything about square roots, you'll know that the opposite of squared is square root. So if I have those two symbols happening at the same time, it cancels each other out and I'm left with just plain old C. But if I'm going to square root on one side, I need to square root on the other side. So square root of 25 is 5. So you remember to unsquare your hypotenuse to get your answer. Another misconception is mislabeling the diagram. Remember, the hypotenuse is always the longest side. And in the equation, a squared plus b squared equals c squared, it's always the c. That's the hypotenuse, because the smaller sides add up to the bigger side. One of the really cool applications for Pythagorean theorem, carpenters still use it all the time. In fact, they call it the carpenter rule or the 3-4-5 rule. The example I gave you on the other slide was a triangle that was 3 and 4 and 5, the dimensions. So that's just one of the easiest ones to remember. So what this man has done is he's put the stakes into the ground. Maybe he's building a deck or digging a pit for a playground or something. And he wants to make sure that this corner is perfectly square. So if you're building a house, that's really important, or building a deck. And what he's done is he's tied some strings off to see if this line and this line are making that 90-degree angle. So what he's done is he's measured 3 feet on one side, 4 feet on the other side, and then the tape measure that he's holding should show 5 feet. If it doesn't, if it's a little short, that means that it's not square and he needs to adjust his strings. So remember that 3-4-5 rule. Pretty handy. Another application for Pythagorean theorem is, believe it or not, baseball. So we have a picture here of the catcher. He's throwing to second base. If you're wondering how far that is, well, maybe you play baseball and you know that bases are 90 feet apart in the major leagues. So this side is 90 and this side is also 90. And so you'll notice that this makes a perfect right angle, and so we have ourselves a right triangle. If we use Pythagorean theorem, a squared plus b squared equals c squared, we know that this is the a and this is the b, and our hypotenuse is always c. So we plug in our numbers, 90 squared plus 90 squared equals c squared. And then you can use your calculator. I got a new one. I don't know how to use it yet. It's really awesome. 8100 is our 90 squared. And then we're going to double that, which is 16,200. Okay, now remember on the previous slide I said to get rid of the squared, you're going to take the square root of it, and that cancels it out and you have just plain old C. Sorry dude, I'm writing on your face. That's okay. Okay, So I'm going to take the square root of c on one side, which means what I do to one side of my equation I have to do to the other. I'm going to take the square root of that. So square root of 16,200 is approximately 127. So does it make sense that the baseline was 90 feet and the hypotenuse is always the longest side would be 127? I'd say that's a pretty accurate calculation. So this man can throw 127 feet from his knees, and in this particular case the guy was out, so good job, catcher. All right, on the pyramid that I drew on, you can't crawl inside the pyramid and measure the height. But if you were standing on top of the pyramid and you dropped a weight down to the bottom, you could say that that is a right triangle. And you could measure the distance to the top. So let's say the distance to the top is, oh, I don't know, 40 feet. Well, let's do metric, 40 meters. And the distance along the bottom is going to be 25 meters. So it's interesting in this case, this is the hypotenuse, right? That is the longest side. So that's one of the misconceptions that you'll find is people always think they're trying to find the hypotenuse. Well, not always. Sometimes the question gives you the hypotenuse and you have to find the other side, which we'll call A. So our formula stays the same. A squared plus B squared equals C squared. And we plug in our numbers. We don't know A, so we have to leave it right there. Our B, which is this guy, is 25. And C is always the hypotenuse, which in this case is 40. Okay, and then you can use your calculator to find your answers here. A squared, we don't know yet. 625 is 25 squared, and 4 times 4 is 16 with a 0 for each one. So now, using preservation of equality, you want to get A squared all by itself, but it has this 625 sticking to it. So let's get rid of that first by just subtracting. And it's gone. What you do to one side, you must do to the other. Oops, 625. So 1600 take away 625, 975. So we are left with A squared equals 975. Now we're still not done because A is not naked and alone. He's still being squared. So the opposite of being squared would be to take the square root of it. So we're left with plain old A, and then we have to take the square root of the other side. Not loving this new calculator, I must say. Okay, 31 approximately. So does that make sense that this side is 25, this side is 31, and our hypotenuse is 40? This seems like a reasonable number. If we got something like 200, we would know that that's wrong because the hypotenuse has to be the longest side. All right, let's do a little more doodling on him. He needs an earring and some funky eyebrows and a necklace. Maybe more lipstick. Okay. See you later.